How's it going, ladies and gentlemen? Mr. Donnie here with some Chapter 10 problems. All right, looking at characteristics of gases and pressure. First question, which of the following statements about gases is false? First option, gases are highly compressible. That is very true, right? If I were to draw a particle diagram, the particles of gas would be really far apart, which is why you could compress them. All right, so distance between molecules of gas are very large compared to the bond distance within the molecules. Absolutely, they're really far apart. Non-reacting gas mixtures are homogeneous. Absolutely. If I were to put in a different kind of gas and mix them together, they're gonna diffuse and distribute themselves evenly. They're not gonna stick to one part of the container. They're gonna spread out and mix evenly. Gases expand spontaneously to fill the container they are placing. Yep. That's absolutely true. You put some gas in a cylinder, it's going to fill up the entire cylinder. It's going to spread out. All gases are colorless and odorless at room temperature. That is not correct. Remember, the question here is which one's false? E, definitely false. All right, number 2. One significant difference between gases and liquids is that a gas is made up of molecules. No, that's true for both of those things. A gas assumes the volume of its container. This is the right answer. A liquid does not do that. It assumes the shape, but not the whole volume. All right, let's take a look at the other options. A gas may consist of both elements and compounds. That's true for both of them. They could be elements or compounds. Gases are always mixture. That's wrong, and E is wrong. So B is our absolute correct answer. Trace. Which of the following equations shows an incorrect relationship between pressures given in terms of the different units? So we got to kind of know, all right, let's say if we had 1 atmosphere, what is that equivalent to? It's equivalent to 101.3 kilopascals, or kPa, which is also equal to 760 torr, which is equal to 760 millimeters of mercury. So this is what we're going to use to do our conversions. So if we were to take a look at D, which is the correct answer because it is wrong, we had 1 torr, and we were to convert that to millimeters of mercury, well, the conversion factor would be 760 millimeters of mercury over 760 torr. So you would get 1 millimeter of mercury. So this is the wrong math. So D is our wrong answer. The rest of them should work out to be the right answers, so all those should be correct. 4, a nice problem. It says the pressure exerted by a column of liquid is equal to the product of the height of the column times the gravitational constant times the density of the liquid, which is given in this equation right here. So how high a column of water would be supported by a pressure that supports 713 millimeter column of mercury at that density? So we're saying that these pressures are equal to each other. So it's the same thing as saying G times H of the mercury times the density of the mercury, because that's our pressure, has to equal the gravity times the height of the H2O times the density of the H2O, because the pressure is the same. So these two products have to be the same. So now we can go, hey, gravity is a constant. It doesn't change. So we're left with this proportion. And we got to solve for the height of H2O. So neatly written right here. All right, so we're solving for this. So we got to divide each side by the density of H2O. And that math is going to be pretty easy because the density of H2O is 1. So we got the height of H2O equals the height of the mercury times the density of the mercury all over the density of the H2O. So if we plug things in now, we got 713 millimeters for the height of the mercury times the density of mercury, which is 13.6, all over the density of water, which was 1.0. And we get, final answer should be 9.7 times 10 to the third millimeters. All right, 5. A gas at a pressure of 325 torr exerts, a force of blank Newton on an area of 5.5 meters squared. All right, so part of the secret here is realizing what the units are. Like for a Pascal, it is a Newton per meter squared. All right, and they're asking for newtons. Well, that kind of indicates what you're going to do, isn't it? All right, well, if I have 325 torr, let me convert that to Pascal. So I go 325 torr, and I go, all right, well, I know if it was 1 atmosphere, it would be, what's it, 760 torr for every 101.3 kPa. So what do we get when we do that math? Beep, bop, boop, bop. 43.3 kilo pascals, kPa. So now why don't we convert that to just regular PA? So kilo means 1,000, so we really have 43,300 pascals, which is the same thing as saying 43,300 newtons per meter squared. And if they tell us we have 5.5 meters squared, you got to times that by 5.5 meters squared. The meters are going to cancel out. You're going to be left with newtons. So do that math and you get the final answer of being 2,4 with 4 zeros afterwards, which would be choice number C. Number C. Good job, Donnie, you big dumb idiot. Well, I hope you found that helpful, and I'll see you in class.